That's interesting. Okay. So let's do this formula sheet real quick, and then we'll see if anybody has any questions. See if I have any answers. So this one starts with the confidence intervals. So there's just 5 formulas. And don't forget that this middle one contains in it a note about when to use T-scores. Right? What's that formula say? You use T-scores when you only know S. Now, I told you this before, and let me tell you, especially if you haven't finished this homework, or maybe you just got this homework back, sometimes I will know the population standard deviation, right? They're going to give it to me. Cool? Right? Every time I take a sample, can I calculate the sample standard deviation? Yes. When am I not going to use that? When I know sigma. If I know the population standard deviation, why the shit would I use an estimate for it? Do you guys understand? So some of you guys made some of those problems in the homework harder than they had to be because they gave you S, but you also knew sigma, and then you had to look up a t-score when you really shouldn't have, right? Because if I know sigma and it's normal, what am I allowed to use? Z-scores. I only have to use T when I only know S. Why would I use an estimate if they give me the real thing? I like it. I like it. Coolness. And then there's this guy for percentages. Yeah, there's sigma. So percentages is Z or nothing. The T-score doesn't really apply for percentages. And then the last 2 formulas from that section dealt with how large of a sample do you need to be such and so certain. So you got this dude here, you got this guy here. I like it. So that's chapter 8. And then chapter 9 gives us not really new stuff, but if you wanted to put this in your notes in this order, it's not a bad idea. So you got this old idea. If you want to, you can also kind of remind yourself that even if I give you S, you still have to do this, of course. And there's still some of us out there that think that this by itself means division or something. Well, what is this again? What is this?
Standard deviation of the sample.
Of the sample means. I like it. So that's just a part of the name. This is just one symbol right here. This is one symbol, something with a subscript. It's one symbol. Sort of like the slope is x2 minus x1 under y2 minus y. I don't know why I said like. But the 2's and the 1's just represent which point, the second point, the first point. This is a standard deviation of sample means. Just a little part of the name. I like it. And then, of course, the kind of new stuff from 9 and 10 was this guy. Kind of borrowed the idea of spread from there. Those don't have hats because I'm not going to, again, for the same reason I wouldn't use S if I knew sigma. I'm not going to use P hat if I know P. And with hypothesis tests, we assume that we do. Like it. What do you think? Is there anything else that I forgot? Oh yeah. Well, there's this guy. Get in there. Right, that's from chapter 10. I will go ahead and be really nice and tell you right now that there will be a problem like that on the test, but it will be a bonus question. Why? I don't know, just because I feel like being...
The very last one?
Yes, so that equation would only be in the bonus section. I like it. I'm going to focus more on single sample stuff. You still have to do that freaking homework, but I decided to be a little bit nice to you on the test, just to see what it feels like. I already don't like it, but oh well, too late to go back on it. Any other suggestions? You can bring in every other formula sheet you've done so far, but anything else? Or
I know for the homework there was like something about like a point estimate or
so point estimate is just another name for best guess, and my best guess is always what I see from the sample. So if I took a sample of 118 gross month students and I found that 37% of them want to move to Canada, my best guess for the percentage of all gross month would be 37%. And then this kind of builds off of that to make a better feel for what's going on. But my best guess, point estimate, is what I see from my sample directly. Point estimate, that was a really bad sequel to Point Break. That's right. Yeah, I was like, I'm not sure. I'm sorry.
What is Z-Stole?
Yeah, what's that little star mean? It's trying to be a star. This is like a starfish that was born kind of weird, but what's a little star mean? It just means the Z-score that came from my sample, yeah. I did that for myself. I did that when I first took statistics. It's not something I was taught. It's not something you'll see in a book, but I'm just like, there's already a Z-score that defines the rejection region, right? And then I just call this one Z-star to differentiate between the two. There's one that comes from alpha, and there's one that comes from me, and that's the one that comes from me, or you. Any other formulas that you guys think should be on there? Anything I forgot? It's completely possible.
Are we allowed to use prop zint? The calculator for prop zint?
No.
Okay.
Yeah. So, I think last time I did point out, it might not be true, but I think I pointed out that there's, in your, when you hit stat, the very last option is tests. And there's the one sample mean, the two sample mean, also for the Z test, the T test. So you could actually use those to check your work, right? And I know it's so old-fashioned to believe this, but I like you guys to know what you're doing instead of know which buttons to push. But it's good to check if you know how to use it. Yeah.
The deviation to check the equation to check error bound.
Oh yeah. All right. So I don't care what the book is. I'm always going to have disagreements with it. So it's always nice to have a disagreement with a free book versus 120. But I hate the way that they ask you the error bound before you even calculate the confidence interval, because they use a stupid calculator just to get all the numbers to magically appear. What part of the equation up here is the error bound? The EBM, like the book calls it.
The right side? After the plus minus?
Yeah, that's the error. This, give or take that, that must be the error. That must be how much I think I'm off by. So that's the error bound right there. I like it.
Times 2, right?
No, you're thinking about p-value?
So, yeah,
There's an equation on the book that says times 2.
Yes, for the p-value if it's a two-tailed test. And what you're thinking about is like the width of the whole interval.
Right.
So if I said, guess my weight within 5 pounds, you could be down 5 or up 5. So you wouldn't say the error is 10. You'd say the error, I'm allowed an error of 5 in both directions. So you don't double it.
So like on the homework, we ask you to calculate the error bound. It's just what's after plus or minus.
Yes, that's it.
So you don't divide it by 2.
You don't multiply by two.
Yeah, none of that.
Well, in the book, like Benji said that you like do it. And you
Oh, no. Are you talking about this symbol they use that I always forget to reference?
Yeah. And then
Okay. This, again, is a subscript. It's a name for the Z-score. This is so utterly unnecessary, but if somebody doesn't ask, I sometimes forget that they put this in there. If I want a 90% confidence interval, let me see. Notice how this is separate from that, by the way. This is not on your formula sheet. Stay with me now. If I want 90% confidence interval, what the hell is alpha? Yes, 10.10, right? Is everybody cool with me so far? I like it. You know, like as much as ever, Jeff, which is not much.
What was the area in one tail?
Yeah. So how much is in this tail? If I had to actually look on the Z-score chart to find it the old-fashioned way, how much area is in this tail?
5.
Half of this. That's all that shit means. The Z-score that corresponds to half of alpha. So I always forget they have the stupid symbol in there. That's all that symbol means. Is the Z-score you would look up, which is half of what the total, because the confidence interval always is a two-tail. Right? Always.
So would we then use the Z-score for 0.10 or 0.05?
If you were looking this up in the Z-score chart, you of course wouldn't look 0.10 up. That wouldn't make any sense. How would I find this Z-score? I would look up that area.
That's if they want the middle of it.
That is what a confidence interval always wants. So that's why you see this symbol for confidence intervals, because they always cut it in half, because there's always two tails. I like it. So is this symbol really necessary? No, it's bullshit. Right? It's just extra shit thrown on top. I just use Z, and how do you find Z? Well, you find Z by what the confidence level is. I don't need it in the symbol to remind me or something, or just to make it look worse, to be honest. Does that make sense? I mean, that's... The book is just trying to be sort of complete, and it's just making it look worse than it really is. Huh?
The book is wrong?
No, it's not wrong. It's just overly correct. If you are overly correct, you're making something unnecessarily complicated sometimes.
So when the homework asks for the error bound, just put was that for plus or minus?
And that's what they do too. Yeah. So I just call that the error, and the book calls it the error bound, because it is theoretically the maximum the error could be. So it is an error bound. So it's wide open. Any other questions? Or if I didn't explain that well enough, you could always say, could you do that one more time, Jeff? Try again. It's always, yes? Sure, of course. That's like the point of today. Has everybody got what they want from up here? Okay. What? Any specific type you want to do? No, you surprised me, Jeff. All right. Let's see. This could, no, I don't want to do that. That would be evil. All right. I can't do that. I'm trying to think of a question I could ask you guys that wouldn't really be too. I was going to say, how many are going to vote for Trump? I'm like, I don't want to do that. How many of you guys plan on voting in the next election? That might be something as I choose not to vote. Well, that's valid. All right. So let's say we feel. What percentage of all of Grossmont do you think is going to vote? All Grossmont students. What percentage? 40%? Okay.
What, the general election or the primaries?
The general election. Primaries would be more like 5%, but and the general election. We poll, let's say 92 Grossmont students. And find, what you got, Jeff? 32 will vote. See how this comes out. I'm just making this shit up on the fly. Test the claim at a level of significance of 0.0, what you got, Jeff? 1, sure. Well, this has come up a couple times. So what does level of significance really mean? 0.01 should kind of give it away. What is level of significance another name for? What symbol? Alpha. I like it. So alpha is 0.01. So take a minute and try to do the first step. Write the claim and what the two hypotheses are. All right. So what's the claim in symbols? No. Darn it. I already started off bad. Mu stands for, mu is mean, but this is a test about percentages. Isn't this a test about percentages? So what symbol do I better use? P. All right. P. What about equals 0.4? Okay. Be nice to yourself. Immediately make it a decimal so you don't use the wrong number in later calculations. So pretty cool that so far? Is that all right? Which one does that go in for?
No.
HO, yeah. Because it's got an equal sign. And what's H1 going to be? So is it a 1 or a 2-tail test? 2. I like it. Not equal to could be either way. 2-tail test. Yes. So the first step is always, what the hell are you talking about? Makes sense. Use what I'm talking about. The next step is, why am I allowed to use what I'm going to use? So how do I do this next step? It's Z or nothing. I might be nice and actually say that and not even include T as an option, because T would never be an option for an NPQ problem. They were invented for sample mean problems. So what do I check? Yeah, okay, so I check NP, 40 times 0.92, no, 0.4 times 92, got it around. Equals something or other, and NQ, which would be 0.60 times 92. So what's that, 36.8? Is that right? It's early, you never know. So therefore, I think that this will be 55.2. Yes? Okay. All right. It's early for me, too. It's early for everyone. Random equal to 5. Check. Which means I can use Z-scores, which really means it's normal enough, so therefore I use Z-scores. How are we doing so far? Is this, so first two steps really should not be difficult. You find the claim. Some of us still think that increased is this symbol. That's disturbing. If you still have trouble with these symbols, that's less than because it looks like an L that fell over. I mean, that's screw the alligator. Shit. I used to live in Florida. I don't want to think about gators. So what the hell are we talking about? What am I allowed to use to talk about it? Then I set up, where's enough evidence, and did I find enough evidence? That's the next two steps. So what's the key things for part C then? How do I set up the rejection region? I know that is what? What do I know that's going to help me with this? Point oh one. Two-tail. And I'm using Z-scores. So what's this going to look like now? Two-tail. Plop, plop. 0.01, two-tail, Z-score. Look it up for me. I know what it is already because I have so many numbers I can't get out of my head. So if you look at the Z-score baby chart, you get 2575. If you look at the T-score chart, you'll get 2.576. I don't care which one. They both are supposed to be something you can use. So I'll accept either one, but let's use the slightly more correct one here. We cool so far? I mean, you know, it's always easy to watch somebody do a problem. That is a very true statement.
So that 0.01 is supposed to be two tails.
Yeah, 0.01 is in two tails.
Okay.
Yep. It's a two-tail problem. So 0.01 two-tail situation.
Why'd you write alpha? I thought alpha was the area in one tail.
No, alpha is the area in the tail or tails. And that's why confidence interval symbol said alpha over 2. Alpha is always the total area. So how do I say this in words? If it's, no, not it's. How do I put this in words?
If Z-score is less than negative 2.576
Or
greater than 2.576.
we can do what?
Reject. HO.
Reject the null because he's the one that thinks it's in here. Right? I mean, that's it. The null thinks it's in here. So if I find something way the shit away from there, looks like that guy's wrong. Looks like the other guy is right. Have I proven either of those statements? No, but I found enough evidence to state that. So the thing about science, it's always saying, I could be wrong. That's why I love it, because that's life. Okay, so now we set up what enough evidence is. What's enough evidence? Well, you got to get there. Then I go check to see what the evidence is I actually found. Did I find enough evidence? So what do we know? What's p hat? Right, 32 divided by 92. I like it. Which is 2 to what? Sounds about right. So 348. Sorry. You can use 78 if you want to.
Yeah.
3478. Okay. No pressure, Linda, but we're all relying on you right now. What's left? Maybe some other people have already done it. And now I just throw it in the formula. I'm going to use the formula that's got P's and Q's in it. Makes sense? So it's my stuff, mine, from the sample, minus what? What am I comparing that to?
Oh, what we think it is.
Yes. 0.40. We always compare it to what the HO thinks it is. Assuming this is right, we're going to try to do something so crazy that it's evidence it's wrong. That's it. That's what this is. So then minus 0.40 divided by the square root of the non-hatted shit, right? 92. P is 0.4, so Q is 0.6. We used that earlier. I really can't read you guys. And let's see, what do we get there? 0.52. You gonna try to do this in your head, Jeff? Yeah. 0.5. 0.05. 0.52. It's just barely over -1, I think. Negative 1.0 something. Oh shit, no, sorry. I got 1. It's non-calculatorless. I must rely on you.
1.018.
That's pretty good, right? Come on. Give it up. So you got that? Yeah? I gotta celebrate my one skill. Come on. That's the one thing I can do. Yay! If I lose that ability, I'm screwed. Screwed. What's that mean by itself? That's kind of a mean question. That means our sample was that far away. Is that far away enough? So our sample just made it just barely one step below what the null dude thought, which is not far enough away. What was far enough away? Way the shit down here. We didn't make it anywhere near far enough away. We made it just barely over a step down, which is still in the null's wheelhouse. It's like, that's around where I thought it was. Screw you, right? So if somebody dropped a bunch of toothpicks and somebody said there's 247 and you counted and there was 242, you're like, damn, right? If you counted and there's like 60, like, get out of here. So this just tries to refine where that line is, where I go, damn, versus get out of here, right? So did we make it far enough away to go damn? No. Only one step down. Who gives a shit about that? So we do what?
Fail.
Fail to reject. We didn't make it. the hoe, fail to support. So what's the only two things you could do with the null? Reject it or fail to reject it. What's the only two things you could do with the high? Support it or fail to support it. I like it. And to be honest, that's the heart of science. We have a theory. We have so far failed to reject this theory. Therefore, that's our best guess at the moment. That's every theory there is. Doesn't mean that it means we have no idea. It means we have really good evidence, but never any proof. Because that's impossible to have actual proof for anything. That's just a fact of life to get over. All right, Jeff, stop pontificating.
That we failed to reject the claim.
All right, now let's put this together. What was the claim? Which one? It was the null, right? So what language am I going to use? Yes, so you're right. We have not found sufficient evidence to reject the claim that 40% of gross most students will vote in the general election. So we have not found enough evidence to say that that statement is incorrect. We haven't found that. We can't reject it. Which in this case is good. We were the ones that made that claim. We're like, oh good, we didn't reject our claim. Yay. You guys all right? What's up? I watch too many zombie movies. Some of you guys are looking at me like you want to eat my brains or something. So here's what the statement would look like. Oh shit, I've run out of room. Let me put it over there. So step E would be we have not found sufficient evidence to reject the claim that 40% of gross one students will vote in the next general election.
You could change the certainty, you get a different answer, like you could say 80% certainty.
Totally. And that's why, now on the practice test it ended up not changing the outcome, but if you change alpha, you could change the outcome. So in this case, well, it would be really hard to let that reject the null. Negative 1.02 is not very far away at all. And if there's one thing I hope right now that you are able to get a feel for, it's what I just said. Negative 1.02 is not many standard deviations away at all. It isn't. If somebody was negative 1.02 standard deviations below the average height, that wouldn't be somebody you would do a double take on. If they were negative 3 standard deviations, you would do a double take. Right? You don't see that every day. That's not normal. Doesn't mean they have something wrong with them. It's just not what's expected. I'm not advocating that you stare at people that are differently heighted. Huh? What? Could be. Especially if it was like Warwick Davis or something. Don't know who Warwick Davis is. Oh, man. Huh? Oh, yeah, yeah. And he was in Willow, and he was an Ewok, and all this kind of stuff. All right. Is that cool? Is that all right? I mean, the only difference between this and like a mean hypothesis test is you would use mu's here. Your z-star formula would, of course, be the older one, x bar minus the mean divided by the sigma. You have to make the new standard deviation. But the idea of the steps wouldn't change at all. You still state what you're talking about, state why you're going to use what you're going to use, set up what evidence would be, see if you have enough evidence. Right, all those steps stay the same. I love it. Bless you. So I think the number 5 is one like this on the practice test. It's a test about a percentage.
What happens when they want you to draw the projection region?
You do that. So you just put your benchmark on the picture. You show me which tail it is, or if it's two tail, you put two tails. Oh yeah. Okay. So everybody got more than they ever wanted. Has everybody got this here? Yeah. Okay. So number 2 on the quiz was just me making sure you could still look up Z-scores the old-fashioned way on the Z-score chart. So if I had I think everybody had a right tail test. So I had a right tail test, and I was using Z-scores, so all the conditions were met for Z-scores. And alpha was, let's do 0.11. So really all this question was, what Z-score has that area above it? That's another way to state that second question on the quiz. So some of you guys had 0.07, 0.08, 0.09, 0.06, I think, I can remember. There are 4 different versions. So then, if you look that up, you would get the negative thing, and some of you guys just wrote that down, but obviously this is supposed to be positive. To get that directly, you would look up what's below this? If there's 11% in that tail, what's below that Z-score? So what is this? Is this a Z-score? It's alpha. What is alpha physically? It's the strongest dog. No.
It's an area.
An area. It's an area. I need the Z-score. So I'm not going to look out here for 0.11. I'm not even going to look at 0.11 to be honest. This is an area. What area should I look up to find the Z-score directly? 0.89. That's an area still. So you look in the middle, in the body. What's the closest you can get to 0.89? Do I have any Z-score? Yeah, I do. So how close can you guys get to 0.89? What do you guys get? 1.23. Kick ass. There you go. Done. I didn't really say to state it in words too, so you can just stop there. Here's my defined rejection region. So if you had 0.07 or 0.08 or whatever, you do it the same way. So I just want to remind you guys, we got to the point where I'm hoping you guys mostly use the T-score chart. But on occasion, you might get an alpha that's not on that chart. You got to remember how the hell to look up a Z-score, what I call the old-fashioned way you look at on the Z-score chart. To remember how to do that, just in case you have some teacher sometime in the future that gives you an alpha that's not on the T-score chart. Whoever that jerk might be. That was nice. I like that. You get that? That wasn't just. Did everybody else hear that? Was that you? Okay, thank God. I'm like, is that the sign, Jeff? Is that the sound? Things are done for you, Jeff. All right, shut. Yes. So, on the problem we just did, the null was that p equals 0.4 and the alternate was p not equal to 0.4, right? So the type 1 error. Sometimes I'll say this as just state the 2 errors that could happen because I don't necessarily require you to memorize which one is which, but the way that I memorize these is the type 1 error is the smaller statement. So you can either reject a true null Or you can fail to reject a false null. Oh, that's type 2 because it's got more words in it. That's how I remember it literally. Okay, I like it. So type 1 error would be reject a true null. So if I'm going to state what this error is, I can say it a couple different ways, but it basically says the percentage is 40%, but we think it ain't. Done. Maybe put some stuff in there about the situation, right? The percentage, what was this about? I forgot already. Gross amount of students who will vote. Is 40%, but we think it isn't. And the type 2 error would be just the opposite situation. The percentage of gross amount of students is not 40%, but we think it is. If you think about it, it only makes sense. Since there's only 2 outcomes that can happen, there's only 2 types of errors that can happen. And does an error mean that I made a mistake in my calculation? No. It's an acknowledgement of the percentage, the possibility that we make a mistake just because we don't have enough information. And the only way you can ever have enough information is to have all the information. That's why there's always a chance you're wrong.
Are you going to ask us to write what it means or just type 1 or type 2 there?
I would just ask you, tell me the 2 types of error.
Okay.
Yeah. So you don't have to say this. I was just reminding you what it was. Right? You're not going to have to state the general. You just got to tell me the 2 things that could happen that would be mistakes. Yeah. Is that all right? Yes.
Can you say the type 2 again
Sure.
for that one?
So it's fail, in general, it's fail to reject a false null. So that's the 2 types of errors are, if the null is true, how could I make a mistake? I could reject it. So I just rejected somebody that was actually telling me the truth. And that happens all the damn time in real life. Or they actually are totally wrong, but I failed to reject. I think they're right. I think I'm like, right? So in this case, it would be the percentage of gross month students. Percentage of gross month students who will vote is not 40%, but we think it is 40%. Blah, blah, blah. So if we fail to reject the null, we haven't been able to say the null is wrong. So we think currently the null seems to be the best thing going. So any theory we have currently, the theory of evolution, the theory of whatever, we could be making a type 2 error. We fail to reject this hypothesis. We think this is the case. And then we do all these tests to see if it's wrong. And there are people that think that scientists just believe in evolution. No, it would be the most incredible day in the world for scientists if somebody showed that it was wrong. Everybody would be like, oh, whoa, cool, let's see what this shit. All right? Okay.
So just to make sure, if Z falls into the rejection region, region, either of the tails, we will support them. I'm sorry, we will reject the null and support the other one.
Yes. I like that. Support the other guy. So if we get into the rejection region, and again, the null always has an equal statement, right? And for that fact, it's always the one that thinks it's in there somewhere. Always. That's why H1 is the one I can show evidence for. I can never prove equality, but I can show evidence that it's not equal to something in some way. So we do make it out here. The guy who thought it was here looks to be wrong. So that's why we call it the rejection region, and that's why we reject the null in that case. He's the guy that thought it was in the middle. So if we get way the shit out there somewhere, looks like he's wrong. We reject the null. Yeah.
So like I wrote down like if the problem is the words like increase or decrease, it'd be like one tail. If it doesn't say that or if it hasn't changed, then it'd be two tails.
Yes, I love it. So if you're not sure, if you're reading through and you can't tell, more than likely it's a two-tail. Because we'll gloss over the word is really easily. We think it's 47% and blah, blah, blah. And you're like, what the shit? The claim is it is 47%, so the alternative would be not equal to two-tail. But if I see a directional idea, we think it's gone up, we think it's gone down, whatever, that will be one tail in that direction. Yeah. Now to me, I gotta say this real quick. I don't know I know a lot of you guys are, like, oh God, statistics. I'm so tired. But you've all heard forever. This has been clinically proven. You've all heard these kind of things for frickin' ever, and you finally know what the shit is going on behind the scenes. You finally see what this burden of proof is before you can state that in a commercial, in an article, online, whatever. And if somebody hasn't gone through this burden of proof, they are full of shit. If they cannot show you enough sufficient evidence, then you have to assume they're full of shit until they can give you enough evidence. So you finally, I don't know, I could have went my whole life and never seen this shit, but you finally see behind the scenes what it is that gets somebody to that point where they can say that. There's always a chance they're wrong. This toothpaste works. There's a chance you're wrong, buddy.
What are the different types of distributions?
All right. I love that question. So what we got?
Is that normal,
Normal. I love it. That's the main one we think of,
proportional?
which uses normal distribution, right? So what you're really thinking about, I think, is binomial. That's the NPQ distribution. Binomial is like the percentage distribution.
Yeah, that's what I thought.
Yeah. So normal, binomial, uniform. Then you have one that's kind of like, we didn't really give it a name, but it's the general one. There's X, P of X. It's just defined differently for everything. It's not a single thing. It's just like, here's all the general probability distributions. And then you've got one more that's related to normal. We use Z-scores or T distribution. Yeah, so you got the T distribution, which is a different shape, but it relies on it being normal to begin with, but the shape is a little bit different. It's not quite as pronounced of a peak.
What are the distributions that have like two humps?
No. I like the dromedary. No.
So you said
Right, dromedaries have two? Okay.
So normal
Camels.
binomial, X P of X, T distribution, and then
Yes, yeah, cool. I like this. You're not going to have to know all those for this next test.
Okay.
Yeah, this next test is going to focus on the normal
Which one will I?
and the T.
Which one will I have to do?
The normal and the T.
That's it?
Yeah. It was the second test where we had the binomial and the general and the normal. Woohoo! Can't believe it's already May. Holy shit.
And I was Cinco de Mayo yesterday.
Huh?
Cinco de Mayo.
Cinco de Mayo. Yeah,
Yesterday.
that's right. Americans are like, reason to drink? Let's do it.
Oh,
Your country did what? We don't care. Let's drink. Maybe some of you guys know the history of Cinco de Mayo, but...
Bought off Napoleon III.
Huh?
They defeated Napoleon III.
Napoleon III. Okay.
It's not Mexican Independence Day.
So there's a whole history behind it, but normally it just gets glossed over. Oh, all right. Let me give you the answer key. So many guys are front of me. Yo. Oh, I'm sorry. Did I totally skip this right? Look in the back real quick. I had like a different version of this test. I just scratched through number 6, and number 6 is the type of error problem. By the way, that if just because it's on there, that formula is from section 10.1, I think, which just has S's instead of sigmas in there. See that? But you don't have to worry about that. That's I scratched through it. I just didn't want to redo the formula sheet. I mean the answer key.
So 6 and E.
Say again, sorry?
5E you scratched out.
No, 6.
Oh yeah, 6.
I think 5E I just put the wrong word. Just to showcase that I'm human.
The one that says extra credit, Robert.
Yeah, that's the one I crossed out. Yeah.
Okay.
5E I just made a
How about the last one?
error. Huh?
Type 1, type 2?
Oh, why is that crossed out?
Oh no, I just did that. I thought you
Don't
said-
cross that out. Sorry. Yeah. I crossed out number 6. The actual number 6 is on there. Sorry, buddy.